Okay, hello. We're here for our first virtual lesson. In order to start with this lesson, we got to build some of the basics, which you may remember from 8th or ninth grade. Hopefully, it hasn't been that long of a summer. So we're going to talk about integer operations. Now, a couple of pieces of vocabulary here. First off, integer. An integer is a whole number, no decimals, no fractions, and it is anywhere from 0 to positive infinity or 0 to negative infinity, meaning that this is the counting numbers 1, 2, 3, 4, 5, 6, and so on forever, but also in the negative direction, -1, -2, -3, -4, so on forever in the negative direction. No decimals, no fractions. And operations is a word that represents things we can do to numbers. We have a couple of examples here. Sum, that's when you add two numbers. Difference, when you subtract two numbers. Product, when you multiply two numbers. And quotient, when you divide two numbers. Okay? Now, a couple of examples here. We have 1 plus -2. Now, this can be simplified to just 1 minus 2. It can be simplified to 1 minus 2. The reason for that is when you add a negative, it's the same as subtracting. So we're going to use our number line here. For sums and differences, we can use a number line, and we're going to start at 1. And from 1, we're going to go 2 to the left. The left over here is how we go towards the negative. So starting at 1, we go -1, -2. And that lands us at -1. Sorry for the sloppy handwriting there. Let's see if we can fix that real quick. And this equals -1. Okay, now let's try one more. We have 4 minus -1. Now I'm hoping we remember that minus a negative is the same as addition, right? Obviously, we all know that 4 plus 1 is going to be 5, but let's see if we can verify this on our number line. We start at 4, we go 1 in the positive direction, and sure enough, we end up at 5. Okay, last one I'm going to try to do is number 4. This one starts at -7, and you're adding -1, which is the same as subtracting 1. That's fully simplified right there. You start at -7. 1 in the negative direction gives you -8. Okay. Now, the number line can only be used for sums and differences. Now we're going to utilize the multiplication here, or product. Product means multiplication. Now, if we have a positive number times a negative number, our result is going to be negative. That shows up right here. A positive times a negative equals a negative. And 9 times 3 is 27. Same over here, we have a positive times a negative, which is going to be a negative. 9 times 9 is 81. It's one of our perfect squares, 81. Okay? And if we have two parentheses next to each other, it also means multiplication. Both of these also mean multiplication. And we remember, just like the negative, the minus a negative here, multiplying a negative times a negative gives you a positive. 4 times 8 is 32. Okay, moving on. Same rules as multiplying. If you have a positive divided by a negative for quotients, remember quotient means divide. Quotient means divide. 30 divided by -6 is going to be a negative. Positive divided by a negative, just like here, positive divided by times a negative or divided by a negative is a negative. 30 divided by 6 is going to be 5. And we need to remember that if we see this fraction bar here, a fraction bar is the same as dividing, So if we have over here -8 divided by -2, we know that negative divided by a negative right here tells us that it's going to be a positive. 8 divided by 2 is 4. Okay. No, 4. Okay, cool. And I'm going to pause the video. Okay, and we are back. Now we have our T, and so moving forward, sorry about that, folks. Vocabulary, some important vocabulary. We need to know the difference between an expression and an equation. We know expressions, as we can see on the picture here, none of them have the equal signs. So when we think expression, think no equal sign. Over here, all of the equations are going to have equal signs. When we think equation, think equal sign. Now, we have again, our equation is all of this, the 3x plus 5 equals 20. The expression is just the 3x plus 5, no equal sign, so we chop it off right there. If we're talking about an expression, we have no equal sign. We actually have two terms here. A term is just a portion of an expression. So these are two different terms. Now, these terms are made up of separate parts. First, we have the variable. We remember variables are letters that represent any number. This x here could represent anything, right? So that is our variable. Our coefficient is the number next to our variable, and we need to remember, though you can't see it, this little multiplication sign is there. So we need to make sure that our multiplication sign is there. Okay, and we have a constant over here. This is called a constant because it does not vary. Variables can vary. Constants stay the same. There's no variable, just a number. Okay, and solving one-step equations. Now that we have covered our variables and constants and vocabulary and integer operations, adding, subtracting, multiplying, dividing, now we can talk about solving one-step equations. Now, to solve this one-step equation, we need to remember basic operations again. Add is one of our operations, subtract, multiply, divide. These are our four operations we're going to focus on. We're going to do one more at the very end, but we'll focus on just these for now. Now, looking at this first problem right here, we need to remember, actually I think we can go to the next slide for this one. Okay, cool. Now, a little bit more vocabulary. We need to isolate the variable, isolate. Remember that isolate means get by itself. So if you want to isolate something, you would take it and remove it from everything else. A good example of this is, as a teacher, sometimes students forget how to behave in class, and what we teachers tend to do is we'll take that student and put them out in the hallway. That isolates the student and isolates the problem. So isolate, to put by itself. And the way that we're going to isolate the variable is inverse operations, okay? Now, looking at this first problem, we have r, forgive my handwriting, r plus 1 equals 3. It is getting a little better though. Now, showing our work is going to be very important during this section, okay? Showing our work. So when we have r plus 1 is equal to 3, we need to remember inverse operations. Now, if the operation here is addition, right, plus addition, then the inverse is going to be subtraction. So if we want to get r by itself, we need to get rid of this 1. We're going to do that by subtracting 1. But we need to remember that if we do it to one side, we have to do it to the other side, right? When we have an equal sign, there's two sides. This is one side, this is another. If you subtract from one side, you have to subtract from the other. Now, looking at this right here, r plus 1 minus 1, you'll notice that they cancel out. These have now canceled out. So what do we have now? We just have r. If these cancel out, we have left r, and the r is by itself, which is fantastic. And over here, 3 minus 1 is 2. Cool. So we have solved this equation, solved. We have isolated the variable, therefore we have solved. The value of r is 2. Now, to erase all that and try one more. Actually, I think there's a cheater way to do this. Let's see if we can do it. Nope, never mind. Okay. And good, that is erased. And now it shows up. Okay, next one, we have n over 3. N over 3 equals 2. Now we want to solve this equation. The way we're going to solve this equation is by isolating, getting by itself, this n. To do that, we need to recognize that this line here means divide, right? We saw that at the very beginning of the slideshow. We need to get rid of this line. That's division. So we're going to multiply, because the inverse operation of division is multiplication. Multiplication. Let's put this up here. Doesn't really seem to be a good place to put that. So the opposite of division is multiplication. So multiplication can be this x, or it can be just a little dot. Both mean the same thing. Okay, and we're going to multiply by 3. If you divide by 3, to get rid of that 3, you must multiply by 3. And if you do it to one side, let's put the line here so we remember we have two sides. We're going to multiply by 3. Now, n divided by 3 times 3 cancels out the 3's, leaving you with just n. Inverse operations, right here, inverse operations should always cancel out. If it doesn't cancel out, you have done something wrong. Equals 6. 2 times 3. And we have solved the equation. How do we know it's solved? Because the variable is isolated. The variable is isolated, or by itself. Okay? Great. Now, cool. There we go. That's the button I wanted. We'll try just one more with the last problem. Negative 3k equals negative 27. And we have negative 3k. We need to remember that this is really being multiplied. So if it is multiplied, the inverse operation is divide. Notice I use this line here to show division as opposed to using the division sign, because the division sign tends to be a little confusing. And we're going to divide by negative 3 over here. Negative 3k divided by negative 3, because we used inverse operation, cancels all of it out, leaving just k. Okay, and we have two sides. I need to try to remember to draw that line. And over here we have a negative divided by a negative. Gives us a positive answer. 27 divided by 3 is 9. 9 times 3 is 27. 27 divided by 3 is 9. And we're done because we've isolated our variable. Cool. And next. Something to keep in mind. Why do we do something to one side? You must do it to the other. I want you to think about a seesaw. A seesaw, that's this little thing here. You've seen it on playgrounds or at parks. And this seesaw, pardon me, this seesaw needs to be kept even, okay? Equal signs mean that there's the same on both sides. So if it's the same on both sides, think of two equal people on the seesaw. If one person is much, much, much bigger than the other, then the seesaw goes like this. We don't want that. That's not equal. Equal is like this. So if you subtract this first example we did, we subtracted 1 from both sides. If you subtract 1 from one side, it ends up being like this. We don't want that. We need it to be equal. In order for it to be equal, you subtract 1 from both sides, okay? Now, last one we're going to talk about is going to be the squared and squared roots. We talked about adding, subtracting already. We talked about multiplying, dividing. Now we need to talk about square and square roots. Square and square roots. Now, this little 2 here is a squared. This little house over the x is a square root. Okay, this is a square root. This is a squared. Now, to solve these problems, let's see if, I guess I'll work down here. We have the first one, square root of x equals 9, square root of x equals 9, if we know the inverse operations, I'm going to put parentheses here, if we know the inverse operation of square root is squared, we're going to square everything. But because of the seesaw, you can't just square one side, we got to square both. And the square root of x squared just gives you x. You used inverse operations, you've gotten rid of it. And this is going to be equal to 9 squared. Remember that squared means something times itself. 9 squared is 9 times 9, which is 81. So this is x equals 81. X equals 81. That's our answer to number 1. Because we have isolated our variable, we are good to go. Now, come on. There we go. Okay, perfect. Now, next one we'll do is number 2. We have y squared equals 36. 36. Now, because we have the squared and we want to isolate our variable, we need to take a square root. And if we do it to one side, we got to do it to the other, giving us y equals the square root of 36. So we need to think what times itself gives us 36. Is it 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6? It's 6 times 6. So y equals 6. But this is where it gets a little tricky. If we have 6 times 6, we get 36. But there's another option there. If we had negative 6 times negative 6, negative times a negative is a positive. So negative 6 times negative 6 also gives us positive 36. So the answer here needs to be positive, that's a little plus sign, or negative. This sign here means positive or negative 6, okay? We don't need to focus on that too much right now, but I did want you to see it, okay? Cool. And I'll let you try the challenge on your own, okay? And good deal. So I gave you a couple of examples to try on your own before you dive into the homework. And as always, email me with any questions whatsoever. Thank you so much and enjoy the rest of your day.